Hey, morning, Costa.
Hey, good morning. How are you doing?
Yeah, doing good.
Great, great. So we are expecting a few more people to join. So we'll
Yeah, yeah,
start in
yeah.
a couple of minutes, right?
Yes, sure.
Okay, great. Uh, okay, people can join in their own time. So we can start with the session. Okay, so as uh, you would be aware of that, we already had the first session where I
Yeah,
told
yeah.
them.
Yeah. I went through the video. Yeah, it was nice.
Perfect, perfect. So today we will dive deep straight into our curriculum, and we'll start with the first module. So what we are going to do in this first module, we will have a kind of overview on uh, the spectrum of data analytics. We will discuss a few terms and terminologies, and we will try to join the dots, like what exactly we are trying to do and what exactly we try to achieve, uh, and all these. So uh, we will start our discussion with a few, key terms and terminologies which rule this particular domain of analytics. Okay, so
Okay.
what are they? Uh, just like the business analytics, then we have uh, data mining. After this, we have machine learning, artificial intelligence, and then finally we have a much used word that is data science. Okay. So if I ask you, like, what is your take on each of these terms being mentioned. So what would be your insights on this? Like, what do you feel about, like mus- business analytics, data mining, and machine learning and all this? What do you?
Business analytics, maybe the requirement of business with they have the data and they need some analysis done.
Okay. Then,
Uh,
what do you think is data mining?
yeah, maybe that's processing the data,
Okay.
large data that we have,
Mhm.
and machine learning is with that data find um, some kind of patterns, we and we start feeding same kind of things for the machine to learn something from the
Okay.
data.
Okay. Okay.
AI is again with that the data that has a good understanding of how it should be processed. Uh, Once the machine learning is done, then basically it's in the I don't know. I don't know how to say that.
Okay. Okay. Fair enough. And I appreciate your, like your insights. So let's understand this with much more clarity. So when we talk about business analytics, it is a framework. Okay. So what kind of framework this is? Uh, Business analytics, it starts with the process of we have a business problem which we convert to a statistical problem. And for that statistical problem, we look for a statistical solution. And finally, we get we convert the statistical solution to an actionable business solution. So let's understand this uh, with a kind of example, because at the end of the day, like, we need an example to understand this. Yeah. So, for example, let's say uh, a financial institution, it has figured out that of late there has been quite a few fraud transactions. Okay, so they want to reduce the number of fraud transactions that is happening on their server. Now, this is a business problem that I want to reduce the number of fraud transactions. Now, if we say that we want to reduce the number of fraud transactions, then we have to set a kind of criteria. Because if we cannot set a criteria, then we cannot measure our success post implementation of a project. So let's say we frame this business problem in a statistical manner that we want to reduce the number of fraud transactions by 50%. Let's say. So this is what we have a statistical problem. Now what we do, we go ahead and try to find, like uh, all the possible reasons behind it, and we do a lot of data analysis, and then we figure out that if a transaction is happening post uh, 1 o'clock at night, and if that is of larger ticket size, then there is a 90% probability that this transaction is going to be a fraud transaction. Now, if we go ahead and uh, tell this to our stakeholders, who are the key decision makers, they will not understand for most of the times. Why? Because for most of the times, uh, like these uh, decision makers, the key decision makers that we have, uh, they are not from the quant background. So they are mostly are from the management background. And if we talk about the quant and all this tech, it might not, like they might not be able to connect with it. So what we have to do, we have to convert it to an actionable business solution, saying that okay, uh, we are almost certain that like the if a larger ticket size transaction is happening post 1 o'clock at night, then it would be a fraud transaction. So what we can do in that case, we can just reach out to the customer and can confirm in some way that they are doing that particular transaction. So that is actionable business solution, that you get a confirmation from the customer that they are really doing that particular transaction. So that is business analytics, where we use a framework starting from business problem, and we reach to a business solution. However, the intermediate steps being the statistical problem and statistical solution. Now, in a lot of cases, we find that there is a lot of overlapping between data mining, machine learning, AI, data science, all of them. Okay. Now, why there is a lot of overlapping, as we will go ahead and discuss all these terms. The reason is business analytics is the framework that is there for a long time. So all of the developments around data uh, started on the platform of like business analytics framework. So this is the oldest framework that we always talk about, and this is the domain that we always talk about, that domain of analytics. Okay, great. Now after that we have data mining. Now data mining, if you ask me, for me it's a process. Okay. For me, it's a process. Now, we will talk about this process of data mining with much more granularity in a while. But for now, let's understand that this process is all about how to extract uh, most insights, or like how to optimally use some data to get to use like to use most of it. Okay, to make the most of it. Okay, so that we can get a lot of insights from the data. Now, following that, we have machine learning. Now, machine learning is a technique. Okay, it's a technique, or because what happens, we have different algorithms, and each algorithm is a kind of technique. So again, we will talk about machine learning in depth, just in a way.
Mhm.
Now, after this, we have AI. AI, again, it's a process. So it's a process of what? It's a process of automation. So when we talk about artificial intelligence or AI, what we do, we automate a process. So for example, like if you look at the application of self-driving car, it's nothing but the automation of
Yes.
the manual labor, right? So if you talk about uh, this ChatGPT, what does it do? It automates the process of generating the context. Okay. So, for example, if I have to write a mail uh, to apply for a university uh, for a research role, so initially what used to happen, we used to think a lot, and then we used to draft a mail, and we would do a lot of like checks on that draft. We would have improved that draft, and then we would have sent it to the university. Now, what we can do, like leveraging ChatGPT, that we can uh, give some prompts to ChatGPT, saying that okay, I want to apply to a university. It's an Ivy League university, and my topic is role of AI in mental health, um, and help me to draft an application. So, with this prompt, what it will do, it will give us a text. Now, if we like the text, then it's fine. If we do not like the text, then we can give further prompt that okay, like could you change this part, could you change that part? So if you look at AI, it's all about automation. Now, over here, I want to mention something. As all of us, like people uh, within tech space and within and outside the tech space, all of us are aware of like huge growth of AI, and there is a kind of apprehension that AI is gonna eat up our jobs. However, like for me, uh, this is not right. This perspective is not right. Definitely, a few jobs will not be there, but then again, a lot of new jobs will be created. So, for me, it's all about staying aware of the developments because we cannot deny the role and the growth of AI. Okay. And what I always say that probably AI will not overtake our job. However, a person who knows how to leverage AI in a proper way would eat up our jobs. So it's the other way around.
Yeah.
Okay. And then we have data science. Now, this data science is a kind of umbrella term. This is very interesting if you look at this data science. It's a kind of umbrella term for me. Okay. Why? Because data science, this can be further. So let's start our discussion with the term data science. Because when we talk about data science, this can be further split into three parts. The first part is data engineering. The second part is data mining, which we have already mentioned. And the third part is MLOps. So what is data engineering? Data engineering uh, is comprised of mainly the activities which help us to gather data from different sources and to make sure that they are being stored in a format or at a place uh, from where it can be consumed for the further downstream activities. So, uh, for example, let's say we uh, we want to develop some models, but for the model, we need the data. Now, what we do, we acquire the data from different sources. Now, once we get the data from different sources, we have to store the data somewhere. Now, when we talk about storage, the data storage can be decided on a lot of factors. So, if we talk about data storage, this data storage or the data storage depends on two factors. What are they? One is the data type, and second one is the purpose of storage. Okay. So when we talk about data type, we know that the data can be mainly of three types. So structured, then over here, let me write unstructured, structured, and somewhere between this, we have the semi-structured data. So for the structured data, we know like for this, we have the RDBMS or the SQL databases, the relational databases. So we have all the kinds of SQL databases like MySQL, then PostgreSQL, SQL Server, Oracle, anything, Oracle database. Okay. So for this kind of databases, we have the SQL or the structured query language to retrieve the data from these databases. Now, when it comes to unstructured databases, we have the NoSQL databases. So, for example, when we talk about MongoDB, Cassandra, HBase, all these. Now, the major difference between a SQL database and NoSQL database is even if we have worked on a single SQL database, single RDBMS or single SQL database, let's say MySQL, yet we can work with multiple SQL databases like PostgreSQL or SQL Server, because there is not much difference in the syntax. It's little adjustment that we have to do. However, with the NoSQL database, it's not like that. Because in the NoSQL database, as we know that each of those databases, they have its own query language. So if I have worked on MongoDB, then that doesn't mean I'll be able to work on Cassandra if I don't know how to write a query on Cassandra. Now, semi-structured, we have these CSV files and others, which is also okay. But the problem is, like what happens for an organization, they have to decide that, okay, for each of the database, each of the kinds of data that we are acquiring, we have to, create different kinds of databases, and we have to store the data there. That can be a tedious task. So what we do, to accommodate all kinds of data, we create something like data lake. Because our data lake can accommodate any kind of data. Our data lake can accommodate any kinds of data, whether it's semi-structured, whether it's unstructured, whether it's structured, any kind of data. It can accommodate. So example of a data lake is when we talk about AWS, it is the S3. The S3 bucket that we create. Example of a data lake is that. In fact, if you talk about Azure, we can use the blob storage for that. So it can accommodate any kind of data. Now, what happens? Let's say initially we are creating a data, we have created a data lake and we have stored a lot of data over there. And from there, what we can do, we can create different databases and we can keep a part of the data in those databases at a later point of time. Why? Because initially like how we used to work, it was through the ETL process, like extract, transformation, and load. However, now we work with the big data. Okay. Now, when we talk about big data has got a few components. Okay, so because the question always remains, how big is big data? So that is determined by a few things. So what are they? What are they? First one is, what is the volume of the data? How diversified is that data? And at what speed that data gets generated. So for example, if we talk about a financial institution, so the number of transactions that happen per minute is huge. So, like, and there are different kinds of transactions that happen. Okay. So the volume, variety, velocity, all are very, like huge. Similarly, when we talk about the social media platforms, large amount of data being generated every minute, every second, and the variety is a diversified kinds of, like data that gets generated. So, like, since now we work with big data, we cannot really follow the path of ETL. So there is a shift. So what is the shift? The shift is from ETL, like extract, transformation, and load, to ELT. That is extraction, then we load the data and then we transform. Why? The reason is, a lot of times this transformation, like, is the prerogative of the data analyst. Because as a data analyst, I know what kind of transformation I might require. It might not be feasible for the data engineers to perform this transformation. Okay. So now there is a shift from ETL to ELT. And that is the reason what happens. Like, we extract and load the data onto a data lake, and then we transform and store the data in respective databases as and when we require. And how do we decide that? On the basis of the purpose. Like, whether we want the data for. So there are two types of data on the basis of purpose, if you ask me. So one is the short-term transactional data. So the first is short-term transactional data that we have, and which we also call as OLTP, online transactional process.
Mhm.
And another way, the long-term analysis purpose. So I will just change this to drop-down transactional purpose. And this is something that we call as OLAP, OLAP, online analytical process. So for this short-term transactional purpose, we use a database. We use a database. So for example, let's say, so what is the duration of this data? It can depends on the amount of data being generated. So it can be for data for a few weeks to probably 3 months or 4 months. Okay. For example, if we talk about an e-commerce, so for an e-commerce, like we have the data for around 3 months in the database before it gets moved to a data warehouse. So why do we have a data warehouse? Because we use the data that is stored in the data warehouse to do the long-term analysis. So for example, if I have to, uh, develop a model on the basis of the last 5 years of data, I will store the data, I will use the data that is being stored in the data warehouse. Now, a lot of times the question comes in that, or the question arises that why can't we store all the data in one database? Why do we need a separate database and a data warehouse? Now, the problem is, so for example, if I am doing the analysis on some data that is being stored in a database, and at the same point of time, we have to update the database as well, then there could be a problem. So that is the reason why we have a database where we keep all the transactional data, and uh, we have another separate data warehouse which we use for the analysis purpose. Now, as a data engineer, what we are supposed to do is to create different kinds of pipelines so that we have a seamless movement of the data from source to target database or the target space. Now, that is the role of a data engineer. Followed by, we have data mining, like when we talk about this data science. Okay, so we have data mining. Now, in data mining, what we do, we process the data to extract insights from the data. But that is not a process which is one dimensional or which is unidirectional. There could be a lot of back and forth movement when we, when we uh, process data to generate insights. However, there is a framework in data mining which we use often to which we use often um, to process the data. Why? The reason is, if we understand this framework, then this process of data mining can become much easier for us. So what is that process? The process is known as CRISP DM. So what is this process all about? It has got a few stages. Now, the first thing is, what is CRISP DM? It stands for Cross Industry Standard Process for Data Mining. Okay. So you can see that this CRISP DM is nothing but an acronym, which stands for Cross Industry Standard Process for Data Mining. Now, what is this process all about? This process is all about step one, that is business understanding. Followed by step two, which is data understanding. Step three, which is data preparation. Step four, which is model development. Step five, which is model evaluation. And step six, which is model deployment. Okay. Now, what is the role of business understanding? To understand the scope of business, or to understand the scope of the project. Because unless we understand the scope of the project, let's say we are talking about the business analytics framework, where the first, the first step was the business problem. Now, let's say the business problem is that fraud transactions are happening. Now, from the data mining perspective, it's important to understand that why this fraud transactions are being so important to us. Like how many fraud transactions are happening, or out of all the transactions that have been happening, what is the share of the fraud transactions? Just give me a minute. Let's- Yeah, sorry.
No problem.
So, when we talk about this the business understanding, it's very important for us to understand the business perspective, like how many fraud transactions are happening, or what is the share of the fraud transactions among all the transactions. Okay. Uh, because unless we understand these things, we will not be able to put things into perspective. It's not like we have got the data and we start working with the data. Because unless we will understand the scope, we will not be able to have the bigger picture. So for that, we have a lot of Scrum meetings, we have a lot of discussions with the stakeholders, and that is how we build up on things. Second is the data understanding. Now, what about data understanding? In data understanding, what we do, we look at we look at the variables that we have. Okay. Second, we try to understand the quality of the data. And third is we try to understand the interrelationship among the variables. Why? Because this gives us a good understanding of the data on which we are going to work. So we look at the variables, we try to understand that what is their significance, what is their role. That can also help us in, in deciding which variables might not be required for the project. Then we look at the quality of the data because, there was a time when we had the impression that machine learning or AI is all about uh, the the quality of the model that we develop. Okay. However, what we have realized at a later point of time being that much depends on the quality of the data on which we are working. Okay. So if the data quality is not up to the mark, then it doesn't matter what kind of models we implement. It's not gonna work. Okay. So it's important to understand the quality of the data and then also to understand how the variables are related among each other. That is also very important for us. After that comes data preparation. Now, what do we do in data preparation? In data preparation, we carry out imputation. So, what kind of imputation? So, probably, let's say there are missing values in the data, and we cannot drop the missing values because there are a lot of missing values in the data. So, what do? We, you know, like uh, we impute those missing values with suitable values. So what kind of techniques we use for the imputation purpose, that we are going to see in the upcoming sessions. Uh, so this is one thing that we carry out, imputation. After that, we also carry out something like uh, transformation, the thing that I was talking about. Like we may have to carry out some transformation like square root transformation or logarithmic transformation or box transformation because uh, doing those transformations are quite important to reduce the overall heterogeneity among the data. Okay, because too much heterogeneity makes the data quite complex. So we carry out these transformations. After that, also scaling is another kind of transformation that we use. And after that, we have feature engineering. This is very important because when we talk about the model development, the success of the models develop on whether we have included the right features on in the model. So features means the variables that would help us to predict something. So if we are not including the right features in our model, then we will not really get the right output as well. So this feature engineering is quite important. Now, when we talk about feature engineering, there are two kinds of feature engineering techniques that we discuss. One is the domain-based feature engineering. So we have the domain knowledge, so we know which variables should be a part of feature engineering. What are the variables that we can create from the existing features? Okay, uh, that is another part of feature engineering. Now, uh, there is another type of feature engineering which is like the model-based feature engineering, which is the dimension reduction technique. We have a high dimensional data. Now we cannot just go ahead and we cannot drop the uh, variables from a high dimensional data just to reduce the dimensionality. So what we do, we carry out the dimension reduction technique. The objective that we have in carrying out the dimension reduction technique is to create components from the existing features. Let's say we have 100 variables. So what we do, we create 10 components from 100 variables. Why? Because uh, that would help us, uh, in not only reducing the feature size, but it will also help us in retaining the information as well. Because the 10 components that we now have, will also comprise of the same amount of information that is being stored in those 100 variables. That is how we ensure that there is no loss of information even if we reduce the dimensionality of the data. Okay, so again, we will talk about these techniques, like in subsequent sessions. Uh, so feature engineering, transformation, imputation, these are all part of data preparation. Why? Because at the end of the day, our objective is to improve the quality of the data so that in the model we can feed the high quality data. After that, we have the model development. Now, in the model development, what kind of models we work on? We can either go for a statistical model, or we can go for a machine learning algorithm. Now, what is the difference between, like a statistical model and a machine learning algorithm? This requires a bit of discussion. So, if we talk about a model, so what is a model? A model is a prototype which helps us to understand how a particular thing is going to work or how a particular service is going to work. So, for example, when we look at the models of a car, okay, we we get an understanding that okay, how this car is going to function. Similarly, if we look at the real estate miniature models, we get to understand that how a project will look like. Now, in the case of business, we also have models so that we can have an idea that what to expect in the upcoming days. Like, if uh, we want to go beyond the time, or if we want to understand the customer demographics, then we should have a model which will help us to create a kind of prototype so that we can address them. Otherwise, we'll remain in the dark. We'll not be able to do anything. So over here, we have these two broad, like we have these two broad divisions. One is statistical model, and on the other hand, we have machine learning. So, what is the main difference between statistical models and the machine learning algorithms? The main difference being the statistical models, most of the times, they follow some closed form equation. They follow some closed form equation first. Second, they come with some kind of assumptions. These two are the main things. They come with some kind of assumptions about the distribution of the data, about something, and also they follow a closed form equation. That is, for example, if we talk about the ordinary least square equation method, uh, we can easily find the different parameters using an equation. On the other hand, the machine learning algorithms, they do not come with any kind of closed form equation. Rather, they learn from the data. Now, since they learn from the data, there are no certain assumptions that get associated with the machine learning algorithm. And second is they're iterative in nature. So it's not like we plug in and we get the values. Now, when we talk about machine learning, there are broadly two types of machine learning algorithms. One is supervised So what is the role of the supervised learning algorithm? The role of the supervised learning algorithm is to predict. So they are predictive models. So the role of the supervised learning algorithms is to predict, that is like a prediction. So to predict the outcome. On the other hand, we have the unsupervised learning algorithms. And what is the role of these unsupervised learning algorithms? Mainly to explore. So a lot of times it is being said that unsupervised learning algorithms are exploratory algorithms. So the main focus is to explore. However, like that is not entirely true because a lot of times we use the unsupervised learning algorithms definitely to explore, but also as a part of supervised learning algorithm. Because when we talk about model development, at the end of the day, our objective is to get the right model. Now, let's say we are developing a predictive model. However, there is, like a lot of heterogeneity in the data. So we have got data from different walks of life. Now, in that case, it will be difficult to, like to generate one model which will help us to address everything. So what we can do rather, we can explode the data and we can create certain segments. And then for each segment, we can develop one model. Okay. So that will also help us in, like in creating the, in coming up with the right kind of model. Okay. So that is the, like we talked about the machine learning over here. Okay. If you see, and we said that we will discuss this machine learning in a while. So that is the machine learning part that I wanted to discuss. After that, we have the model evaluation. So what we do in the model evaluation? It's an experimentation process that, like we develop multiple models and we try to find out that which one is working the best. And then finally, deployment. Now, what is deployment? Deployment can be of two types. One is implementing the insights. So for example, let's say we were working on a project of employee attrition. So we have taken up a business, like this, data mining process. And what we have done, we have figured out that, okay, which employees are more prone to leave, are more prone to attract. So what we can do, uh, we can have a word with them and, like we can try to find out the right way to retain. So implementation of insights or productionization. So what is productionization? The model that we have generated productionization. So what is productionization? That we have generated a model or we have developed a model. Now what we want to do? We want to create a web application and want to embed this web application within our website. Okay. So that is also another way of deployment. Now, if you look at this particular process, it may happen that at the evaluation stage, we find out that none of the models are really performing well. So now what we have to do, we have to go back to the model development. Now, if we go back to model development, we may find that the kind of model that we want to develop now, it can't be done unless some kind of data preparation is being done. So we may have to go another step backwards. Now, when we want to apply some data preparation, we may find out that we cannot achieve it unless some data quality issues are being taken care of. So there can always be a back and forth. There will always be a lot of back and forth being involved. Or it may happen that when we go ahead and when we present the model in front of the stakeholders, they say that, okay, like the models that we have come up, they're not working. Okay. So there can always be a lot of back and forth. But the most beautiful part of this particular framework is, if we remember this framework, if we follow this framework, even if there is a lot of back and forth involved, still we will always know at which stage we are, what we want to do over here, and where do we want to go from. Everything will be very clear for us. Okay. So that is why this framework of CRISP DM is so efficient. Okay. So that was it. That was something that I wanted to discuss on the very first day of the training, because that will help us to connect with all the things that we are going to do in the upcoming days. So in the next session, that is like on Thursday, what we are going to do, we will understand the role of statistics or the quantitative techniques, because again, when we talk about statistics, probably we have understood or we have come across a lot of formula and everything in our high school or graduation or during our academics. But over here, we will not really focus on the formula part. Rather, we are going to focus on the pragmatic part, that how we leverage statistics in pragmatic data analysis. Okay. How do we leverage statistics in understanding the quality of data? How do we leverage statistics in understanding the relationships, in strategization, all these. And once we are done with that, then from the next, from the next week onwards, from the upcoming week onwards, we will start working on Python directly. Okay. So that is going to be the plan for the upcoming days and upcoming weeks. Okay. So, hi Hima, how are you doing? I think you joined late. That is why, I didn't get a chance to interact with you. You there? Probably she's not around. Okay. Anyway, so that was it. What I'll do, I'll share the recording with you guys. So go through the recording and feel free to let me know for any kind of questions that you may have. Right. And
Yes.
see you on Thursday. Same
Yeah.
time.
Yeah, thanks, Christopher. It's a lot to process in one day. Hopefully, I'll go through a couple of times and make sure that I get everything.
I do agree.
Yeah.
Not to worry. I will share the recording and feel free to reach out to me for any kind of clarification, any questions that you may have.
Sure.
I'll be happy. Okay.
Yeah, sure.
Great. Take care. Have a nice day.
Yeah. Have a nice day. Bye.
Yeah.